Morning, and hello everyone, and welcome to today's session. As Sheriff introduced me, my name is Ramesh, and I look after the education program in manufacturing space for Autodesk. And also, I would like to, introduce my, today's presenter colleagues. I think which is already introduced, Mr. Anand Pujari, and Mr. Badari. So today, we are here to, explore. Limitless possibilities of which generative design are using Fusion 360 technology. And now the technology really, stands fundamentally to reshape the engineering and design for manufacturing. And also we are looking at some, intelligent tool, in today's session. So, all of you know, like the future is here, and as Autodesk company, we are bringing that radical change in the way the things are designed, made, and also used. So here are some, examples, of the incremental innovation and the transformational innovation. So these two things are important because to move into a generative design role and trying to understand the technology, the benefits. Okay. So the one of the thing is the manufacturers strive continually innovate with the design of their products, and that's why we have seen what is called as the shift in the product innovation platforms. Okay, so I would like to give these three examples here. These are really important examples, and I would like to give the first example, which is about the unmanned aerial vehicles. So this is the example of a company which has created a branding a new market in this space, and this is really truly amazing story of growth because in 2011, so DJI posted around 4 million of revenue. In 4 years later, I think the company has posted around 1 billion revenue for 2015 also, and this is triggering almost 996 growth in 4 years. So you can see the kind of model and the innovation that the company have adopted. So the next example, you can see on the left hand side. This is the example of innovation. It's completely rethinking of a fundamental necessity and creating the brand new product. So what is this product all about? The number one is this is the product called as BioLite, and this is born out of the need for providing the families with affordable source of energy to charge the mobile phones and LED lights. And this store, I think this is one of the innovation in the world which is capable of generating the electricity from its own waste heat while reducing the toxic smoke emissions by 90%, which is enabling the use of off-grid areas where the stores are most needed. And the final product in our re-innovation is this is all of this is a hype of self-driving cars, and I think started 3 to 4 years back. But the major companies like Mercedes-Benz are racing each other to make this reality, and I think we can expect to see some self-driving vehicles on the road over the next couple of years. What's the problem?
Sorry to interrupt.
Yeah, I think yeah. So the next, I'm going to talk about the productivity. I hope you can hear me.
Just a second. So there is a technical glitch. We are not able to see the presentation for the audience. The audience are not able to see the presentation. Give a minute. So we'll confirm from our end, and then we can continue the session. Is it okay, sir?
Yeah. So shall I pause for some?
Yes, sir. Just a minute, because right now the audience can see only Anand Pujari's screen, so the presentation is not streamed to them. So we're just looking where it went wrong. Just give us a second.
So can I stop and share once again? Share the
Do you want me to log out and log in? Do you want me to log out and log in? Maybe I log out and log in so that.
Okay, fine,
no,
fine.
I think the best idea is I can reshare the the file so that probably.
Good morning, everyone. So my name is Badari. Sorry for all these technical glitches. So definitely we can export this on the virtual platform. Extremely sorry for the inconvenience. So at this point, I'm going to start with the Fusion hands-on. So later, Mr. Ramesh Pudale will continue with his presentation so that he can give more insights on this particular technology. So before that, so we are going to have a hands-on. So hope you will be able to follow these things. And I hope many of you have already installed the software. And if you launch the technology, you can find a very cool user interface. I'm not going with all the basic things because that will take about 3-4 days. I'm not going to spend so much time on that, but I'm straight away jumping into this generative design part. So today in this generative design, we are going to start with the quadcopter design. How we are going to create the quadcopter. So basically, we know what is the requirement of the quadcopter, and at the same time, we know the functionality of that, what exactly it is supposed to do. So we use quadcopters most of the time to carry the camera. So sometimes even like nowadays, I hope you have heard about Amazon is planning to deliver the parcels to the door-to-door using drone. That is what they are planning. So it's already executed also in some places, some region. And so this is exactly what I want to do. So now in my case, I want to design a quadcopter drone, so which can carry a camera of 12 kilo weight. So that's the whole idea. So how I'm going to start with. So most of the time, we will be having an idea what exactly we are trying to do, and we won't be having an idea how to design that particular model. By the time of designing, so we won't be having any idea whether this can take the load or not. That will take a lot of time for you to execute or amend the model again and again, depending on the requirement. And sometimes we will not be aware how we are going to manufacture that, whether it is using a 3D printer, whether it is using a CNC machine. So considering all that, just imagine you are giving all those inputs to your design software, and software will generate that particular model for you, right? So I'm going to start with a simple quadcopter drone design. So where this is my Fusion 360 screen, you can see the basic module. I'm working on this design module, and I'm going to start with a simple sketch. So here I have a create sketch option. So simple sketch, I'm just going to create a circle. So where I'm supposed to place my quadcopter battery and all the PCB systems. So that I want to place it in one particular location. So I'm going to design that area. So I'm trying to create a circle with diameter 120. Okay. And one more circle to give the thickness here. So this one will be 100. Right. So finishing this sketch, I'm going to extrude this particular profile. So this height, I gave it as 100. This is the center of my quadcopter where I'm going to place my battery, controllers, everything inside this. Okay. And the next thing for the quadcopter, we need to have a place where we are going to fix the motor and the blade. So I'm going to create one more sketch here. Right. So let me just start sketch. I'm going to create sketch on the top plane. So I will create circle here. This one's supposed to be like 60 diameter, and the thickness supposed to be 10. I'm going to create one more circle here. So this is 50. Okay. Now the dimension for this. So I'm going to create dimension from this center. From this center to this center, axis center here. This is supposed to be 200. And the same vertical. So this dimension also I'm going to take it as 200. Okay. Now, finishing this sketch, I'm going to extrude this again, extrude this particular profile towards bottom. This is minus direction. So I give this as minus 50, 50. So obviously, quadcopter, we need to have 4 components where I can fix the motor and blades. So I just have to pattern this particular model here, circular pattern. This whole thing I'm going to create pattern. And the axis will be the center. And the number of quantity, so I change it to 4. This is the basic design, basic idea what I have. So I need this big space to place my battery and all the control, everything, PCB. And next, these are the 4 places I need to fix the motor and blade. This much knowledge I have at this point. This is the basic thing. Next, I'm not having any idea how I'm going to connect all this, what should be the shape, the best shape so that I can reduce the weight. I can have a minimum weight on this so that drone can fly properly. First thing. Second thing, the manufacturing criteria. And the third thing, load, how much load it is supposed to carry. To consider all these things, what I'm going to do now, I'm going to start with the generative design. Once I click on the module, so here you can see the generative design. After selecting this generative design, you can notice, so the complete user interface will change here and you can notice the toolbar. The best thing. So once after completing this, now here, there are a couple of things you have to notice. So first thing, if you go to guide, software will help you to understand step by step how you are supposed to use this generative design module. Okay. And the next thing, very simple way, it has been explained. So first thing is study. So you can have multiple study on one single file. Model, if you want to edit the model, then couple of things we have to consider, that preserved geometry, obstacle geometry, then loads. So basically I'm going to start with, these are the locations, as I mentioned, I'm supposed to use for my drone. That means this 3D model is my preserved geometry. I must have this 3D component in my drone design. So this is a preserved geometry. So here, so I was talking about the preserved geometry. So I have made all these components as a preserved geometry, which I'm going to include as part of my drone. This is must and should. So those components I have included here. And the next part, so here I have an option to ensure the obstacle geometry. The obstacle geometry is something where we do not want to have any 3D solid field. So I need to have a sufficient space over there for my other, all the 3D model what I have created. So that is already a preserved geometry. So what I'm going to do, I will select edit model, which is only applicable to this generative design. So whatever I create here, that is not visible on my Fusion 360 design screen. So selecting this edit model, I'm going to create a simple 3D space. I'm creating a sketch on the top of this plane. So I will create a triangle here. So these are the space I don't want software to consider as part of the, you should not fill this space. So I just want this to be available like a proper free space. So I'm selecting all this. I'm just mirroring this. Okay. So finish sketch. I'm going to extrude this particular portion here. Okay. And the same thing, I will try to create a pattern, circular pattern. Of this particular thing. So axis, this center I'm going to select as axis, then quantity 4. Okay. Sorry, it's not selected properly. Pattern, circular pattern. I'm selecting this component. Okay. Axis, this is the axis, then quantity, I will select 4. Something wrong. Okay, let me just edit the sketch. So where there itself I can create the pattern, hopefully. Circular pattern of this one. Model. You can notice there are 3 additional pyramids are here. So which is not visible in my design. This is only part of the generative model. So these things, I will convert that into obstacle geometry. So that means there is something is going to come here. So software should not consider this volume to fill with generative design, right? So that has been turned to red now. So these are the preserved and these are obstacle geometry. Very simple. Then after that, the next thing which is very important, that is load and constraints. By the time designing the shape, so filling the material, software will consider the load. So the stress, what or the load, what is going to be on this top of this, or which will be handled by the drone. So that will be considered by the time of creating the shape. So now, selecting structural constraint, what I'm going to do, I will select this drone base as constraint. Okay, this is the fixed geometry structural constraint. You can see the icon also visible here, fixed constraints. And then this to take the load towards top, right? So I'm selecting structural load. I'm going to select the top face of all these what exactly you want to achieve. The first one, objective. Objective of this particular drone, why I'm using generative design, is to minimize mass. So all the drone, normally we prefer to have a lightweight so that it doesn't require heavy battery or heavy motors. So I want to reduce the overall weight, but it should be capable to carry the load which I have given, 100 Newton. So minimize mass. So safety factor as per the standard, so it is showing 2. So that I just want to continue the same. So I will select OK. And the next very important part, manufacturing. How we are going to manufacture this. More and more manufacturing method, if you select, software will give more suggestions or more shapes to consider. If you minimize the number of manufacturing method, you will get the less number of shapes or consideration. So here, unrestricted additive manufacturing is tick already. So I consider this to manufacture using my 3D printer. Okay. And so overhang angle, so depending on the 3D printer, what you are going to use, that minimum thickness that you can specify here. So considering normal 3D printer, so these are the basic inputs, default inputs have been given. So I just want to continue the same. At the same time, I also want to consider the manufacturing method using CNC machine. Any of these shapes definitely cannot be manufactured using lathe. That should be milling. So configuration, milling, by default it is showing 3 axis. If you have better CNC machine, you can even change it to 5 axis. So I want to consider 5 axis so that software can create very complex shape. So I'm activating this 5 axis here. Okay. Activating 5 axis here. After that, now minimum tool diameter. So depending on your CNC capability, tool shoulder length. So what you are going to use on your CNC machine, the shoulder length, and head diameter. So depending on the machine tools, what you have, you can give the input to software. So this is the best part. One is additive manufacturing. You can give input based on your 3D printer, what you are going to use. And the type of CNC, whether it is 3-axis or 5-axis, you can select. Then you can specify the tool information. Okay. So I've selected both here, additive and subtractive manufacturing method, the 3D printing and CNC. Then once after, if I select OK, the next part, material. This is more important again. So which are the materials you want to consider for the manufacturing of this particular quadcopter? Once you click on the material, software will load the material library here. And these are the inbuilt different material compositions which are available. Metal, plastic, both are available. So library, you can search in the Fusion 360 library. If you know the material composition, you can add or create your own material library. Okay. So now, for example, from metal, I would like to consider this aluminum, ANSI 10 mg. I'm going to drag and drop that material for the method consideration here. Again, inside the method, you can use additive or milling. So which one you want to consider this material for. So I don't want to filter that, because nowadays even like you can use 3D printer for metal manufacturing also. So I'm not going to limit that manufacturing method. So I'm just considering all method, and I'm trying to include couple of different material for the consideration. So here I'm going to select this aluminum, which I have already loaded, and I'm going to select Fusion 360 normal material library, where I can look for metal. So aluminum grade, I'm going to select 1100. Okay. Then I want to consider inside this plastic, ABS plastic I want to consider. Okay. So additional to this, so which all the material you want to consider, you can select all this material. You can just drag and drop to the InStudy material library. Okay. So as I mentioned, these are all the inbuilt library with Fusion 360. If you want to create your own material, you can right click, you can go to properties. By editing all this information, you can add your own materials. That is not a problem. But right now, in this case, I have selected 3 different material: aluminum, ALSI 10 mg, and aluminum grade 1100, and ABS plastic. So most of the things already I have given input. And the next very important thing here, you can see pre-check. By clicking on this pre-check here, you can see software is giving some warning. All this warning or something will be related to the material cost or the manufacturing cost. But because here in India, we have not uploaded that particular information to the software, so it won't be able to give you that information. So here you can see the studies geometry may be too large to be 3D printed. It may affect the ability to estimate the manufacturing cost. Right? So that warning, so if it is showing in this kind of icon, you can ignore. If it is showing the red dot button, that means that is a warning where you have to repair your model. So before you execute. In this case, I can ignore these warnings. I can just close. And the next step here, you can see previewer. This previewer will help you to understand how this is going to be like executed, what would be the shape software which is going to generate. By selecting this previewer, the software will start creating the previewer, that the kind of water wave kind of visibility will be there about the material and the shape. So software is generating that previewer. It will take a couple of seconds before you execute your 3D model. So I just want to repeat the whole process here, starting from, so I have imported the 3D model, or once I start my generative design. So the basic 3D, whatever I have created, is available here. And the existing component which I want to secure. So I'm selecting that as a preserved geometry. I have selected all these 5 cylinders, and I have created this triangle using the edit model function, so that I can create that into an obstacle geometry where I don't want software to fill any material inside this volume. Then I have given the constraint. So I have fixed the constraint at this bottom, and load towards top that I have given 100 Newton here using the structural load. And then, so the objective of this particular design. So I want to achieve the lightweight drone which can carry the load which I have given 100 Newton. The objective is to minimize the overall weight. Manufacturing method, I have given 2 different types of manufacturing method, additive manufacturing and subtractive manufacturing, where in the subtractive manufacturing I have given 5-axis milling. So the software can consider even complex shape to design. In the material, I have added 3 different materials, 2 aluminum class, and I have added 1 ABS plastic. Okay. So after that, so here you can see software is creating the shape here. You can notice here. So there is no volume inside this particular triangle because this is the obstacle geometry. And software is adding all these cylinders to be part of this particular quadcopter. So this is basic preview, how it might look. But this is not the shape actually. This is just where exactly software is filling the material. The overall boundary, software is giving an idea. Once after that, you can stop previewer, okay? And then here you can see generate. By clicking on this generate, so software will show the particular study 1. So that is generative design model, okay? And this process is not on your local computer. Let me highlight. This process doesn't happen on your local computer because this overall process, considering the load, manufacturing method, everything, software supposed to generate the shape. This process happens on cloud. Okay. So in my case, I have unlimited cloud credits, so it is not highlighting the cloud requirement. So it is just blank. Okay, but maybe in your case, you might see here, if you are using a 1-month trial version or something, it will give some limited cloud credits. So that will be highlighted here, how much cloud credit it will take. And once after all this, I can just click on this generate one study. Once after clicking this generate one study, it is asking me to save the file first. I am saving this as a drone test. Save the file. Okay, now you can notice the software started working on this generative design, creating the solid 3D model, and you can notice job status is on cloud. Okay, and the status, it is not yet started. It will take couple of minutes to execute the 3D model. And of course, you can just imagine I'm creating something, I'm generating something, considering so many criteria. Whether it is manufacturing, whether it is additive method, whether what exactly I want to achieve, so that I am supposed to reduce the overall weight, and I have to maintain the stress, strain, considering the load, what I have given 100 Newton, and I have to maintain the safety factor of 2 as per the standard. So considering all this together, software is generating the model. And you can imagine the time and the process which takes in the backend. So all this process going to happen in the backend. So I can just close this window, and here you can see. So software start updating based on the backend process. So once it completes any model, automatically all those models will be visible on your screen. Rather than model, I can say these are all the suggestions. Okay. So now, this will take about 20-25 minutes. I don't want to waste that time. So I have already created the same thing And here you can see how this previewer looks. The same screen here. So right now in this particular exercise, it is still started. Okay. But once after it completes it takes about half an hour, 25 minutes or something. Then after that, software will give you all these inputs. In this particular input, so which one suits your requirement? Okay, that is most important. So you have to decide as a designer, it is your role to decide which one suits best for your requirement. In these cases, if you look at this, so there are more material filled inside this. So I want to consider this study 2 here, okay, generative outcome 4. I am selecting this. Once I click on this particular study, software will open that particular study, that particular model. And here you can notice this is how it is going to look. The component which you have already given as the preserved geometry, that is still there, no change here. But software added material in all the remaining area. Okay. And that particular model, so overall information, so that you can find it here.
Yeah. So,
Status, converts,
I
material, ABS, plastic, orientation. Sorry.
Yeah, Badri, I would like to add here. I mean, this is really interesting, which is going on. So all of you seen the process here. It's completely the system goals that what we have given. We have given the constraints, and there is a inbuilt algorithm which synthesizes the solution. What you can see, there are several alternative drone bodies that the generative design is creating for the given goal of solving against the force, of the lift, and of course the lift of all the 4 propellers that you've seen, and also the gravity load of the battery. And it looks like you're seeing the process of erosion. So what is meant by erosion is, how the process happens is, on the first, iteration, the algorithm does not know where to start, so it inserts the block of material between, let's say, the propeller mounts and the battery housing. Then it removes the material, all the material which are not needed to accommodate the loads, and the stress analysis is run at every iteration to check the progress, and it keeps iterating, to satisfy the load conditions, and then it starts again with a different material. It could be sometimes it could be a polycarbonate, or you can apply aluminum or nylon as well. Okay. Yeah, so this is something, the process behind what you can see the drone body, and right now we are looking at different types of the outcomes, the generative outcomes, where on the right hand side, if you look at, we have all the properties over there. Yeah, but go ahead. Thank you. Yeah, so let's cut in this process. I think what we have seen is maybe you have your software Fusion 360 up and running on a system, and probably you have seen the capabilities of Fusion, and one of the capabilities is of course about generative design. And with this technology, you will get all the optimized results, multiple validated and manufacturing ready options, and these options you can see in the Explorer, and all these CAD outcomes are real exciting. So we can take these outcomes and optimize designs, and we can go ahead for manufacturing. Sometimes there is one more possibility where we also looking at the interesting option, which is called as the design for manufacturing. It could be additive as well as subtractive. So this allows us to generate the design process, or the different design options by using the constraints which directly comes from the materials, the processes of additive, and then we can put these constraints in the workflow. The another is benefit is if you have multiple parts, right? There is you can also maximize the potential of these manufacturing methods by combining multiple components into one solid part. Where generative design plays really important role, and you have a wide range of multiple design options, and you can do a review, different types of trade-offs in materials, understand their performance and different types of manufacturing methods. Yeah, so let me you also continue that we support both 5-axis, 3-axis milling, as well as we support the 2 and 2.5 axis. There are some special algorithms for beam structures as well. But the primary this option allows us to give completely different solutions we never thought of, and this technology is completely manufacturing aware. We will have tens or hundreds or thousands of high performing design options. Then also it's, as I mentioned, it is manufacturing aware, or we can use the multiple materials. We have open design space exploration. That's pretty cool in this on this platform, multiple production methods, and the CAD ready geometry. There are several examples here we want to cover at the end. Okay, so but in between that, I just want to give a highlight of some of the top companies who has actually implemented, and we have the commercial outcome as well. Okay, so as we have seen the corporate chassis, right? There we have seen the obstacle geometry. This is basically I would say the negative geometry, and we have a green geometry which is called as preservative geometry, which is also called as positive geometry. So based on your all mounting points, we can keep all those preservative geometries, define what is called as the obstacle geometry, apply the boundary conditions like the different types of constraints, the different types of load cases, because these load cases, it's not a single, but it could be a multiple, and these load cases are also depending on your design objectives. Suppose you may have your design objective with the minimizing the mass, okay? Or sometimes there may be a design objective for maximizing the stiffness. Okay, so all these scenarios, I mean, it's really interesting, to see that with AI and cloud computing, you're able to augment the existing ability of your design with the help of your teams, as well as your single person, one human, and with artificial intelligence, unlimited cloud computing power, you'll have hundreds and thousands of design options. Okay, so this is a new way of looking at how the design exploration space, and that is completely limitless, and with the possibilities for any students to to consider. Okay, so Badri, are you back?
Badri is not back. Maybe you want to continue with your presentation, Ramesh. Badri, are you back? Badri, can you hear us?
My presentation is not live, right? So I can't go ahead.
It's not live. Your video is live, but the presentation is not busy. Sharif, can you?
Yes, sir. Ramesh sir is not live, so you can continue with this, and I'll meanwhile check with Mr. Badri.
Yeah,
his presentation has to be live.
All right. So let me talk about, because I think if it's not live, but which screen now you can see on
it's the first screen. It's your main screen that has been displayed.
All right. Okay.
Otherwise, do you think we should talk about the success stories? I don't know.
No. I think success story you can talk about But yeah, the primarily the overall Fusion 360 is completely I would say it's a cloud-based CAD CAM tool for collaborative product development, and here Fusion 360 enables the exploration and completely iteration of the product ideas, and collaboration within the distributed product development team, and this is something which is new, and everybody can also look at.
Sorry, there was an internet connection issue. So should I continue or?
Yeah. I think, Badari, are you back?
Yeah, I'm back. If you want to continue, you can continue.
No, I can't hear you. So I thought if you are not there, so in meantime, I was talking about the other theoretical aspects of generative design. Yeah, Badari, you can continue now. You can share your screen.
So I was somewhere here. So there I was talking about the information what software is giving about the particular shape which it has been generated. So here you can notice the material, the overall functions, and here you can also notice the volume and the overall weight. So the overall weight of this drone, which can carry about 12 kilo load. So software has generated that particular model with 2.77 kg. So this is one consideration. So once I finish outcome this view, so I can select another one. Okay, so if I want to consider multiple, so then I can select multiple model together. Then I can explore this particular model together. So where I can easily compare the model, and at the same time here I have options also available. There I can finish exploring and going back to this, the individual, that particular selected model, for example, so this one model which I really want to extract to my 3D model. So I can extract that particular object, that shape, to my design space. The same thing I have exported to my design space from this particular suggestion what given by the software, right? So one second. So just internet connection issue. It's showing my job status is offline. So I'm trying to go online so that I can explore more. Sorry for the inconvenience. There are some technical glitches here. Just give me a second. Okay. So here in this, so I can compare with the multiple model at the same time. So here I have scatter plot preview. So where you can notice the different material. And so here you can see the safety factor, and here it is the load. So I'm going to select the minimum weight. So that is starts from 1.75, so plus odd some kilo, and the safety factor. So clicking on this, for example, the safety factor is minimal here. So I want to go close to this. So more safety factor. So here I can select this particular, which is 2 kilo, and this material is medium density, so fireboard material. So once after I select that, software will show the preview of that particular shape. Right? So this is outcome 12. So inside this different outcome, I can select that particular outcome 12, right? So that same thing, I can export to my 3D model. For example, so here you can see the option available, create. So design from outcome, mesh design from outcome. If you're looking for the normal CAD ready output, you can select the design from outcome. So once after you select, software will show again the cloud credit which is required to export this particular shape into your 3D model. So by selecting that cloud credit, you can select this create design. So once after you select this create design, the same shape, whatever you have created, that will be exported as a separate file, Fusion 365. And how it looks, it exactly looks like this. this is your actual 3D model. Okay. So this 3D model is exactly the same, whatever you create, like using extrude, revolve, all the functionality. It is same like that. If you further want to edit this, all the shapes created by generative design are all free forms. You can see this is CAD ready 3D solid. For example, here, I want to have this complete space. I want to open this up. So same, I can go to extrude command. So I can select that particular profile to extrude, right? So now, for example, I'm going to create a circle exactly at the center. Then I can use the extrude function. Selecting this profile, I can cut the material. Can you see? Even though it is generated by generative design module, but still it is a normal 3D solid which you can edit further. Even the shapes, all this, the freeform shapes which you can see, that shape is also editable by going to freeform. If you want to change the shape, you want to fine tune. So this, you can fine tune further to bring the final output. Okay. So started with the thing. So we have started with simple cylinder in this particular model. What you can see here, we started from here, added input at the generative design. We have given the preserved geometry, obstacle geometry. Then we have added the load. After execution, software will give the multiple output. So here you can notice, depending on the material and manufacturing method, and the same thing you can extract to CAD ready model or solid model, and that would look something like this. Okay. So I will hand it over back to Mr. Ramesh. So he has missed the initial presentation because of the technical glitches. So I hope he can continue with his presentation. Then later I will take the question and answer section.
Done. So we have made you as a presenter, but the sharing seems to be from your end.
Yeah. So let me, I don't know whether you can, I mean, all of us see the screen. And here, as you know, Badari has, given the options regarding, he spoke about, different types of manufacturing options for the, for this drone frame. But as we are supporting, most of the manufacturing methods like additive, as I mentioned, the interesting, one of the method and the key requirement is also about the die casting, 3 and 5 axis milling, 2.5 axis, and also 2 axis cutting. Now the 2 axis cutting is fantastic because most of in Indian workshops we have this facility, and based on your shop floor requirement, you can put those manufacturing constraints in your generative design study. Okay. Let me go to the next slide. See, here is another project where we also talk about the generative design. With this is the example of an G engine bracket. I'm not sure whether you can see my screen, but yeah. So here we have synthesized a new bracket to meet the performance criteria, and the one which left actually also has some weight optimizing criteria. But on the right there is a similar the similar part which was generated by the generative design, but it's lighter than the previous one. Okay, so we use lattice structure optimization in the whole process. The another, it also mimics bone structure by adding material only when it is needed, and we can also remove when it is not required. This is based on your the stress concentration area. If we have higher stress concentration area, you'll get more dense the lattice structure. And this is a new class of algorithm. It's so intelligent, that it will make the complete bone structure. Okay. But as it is computer, it's really fantastic to have and create these kind of hip bones as well. So this is one of the examples of doing the further optimization for this. One of the exercise is about the beam structures in the generative design and the algorithm used to resolve the loads and find completely a global shape. And another algorithm which is used to optimize the individual beam in the partition. And all of you seen the FEA. In FEA we have the element stiffness matrix. We have the global stiffness matrix, and based on that, what we do is we apply a FEA at a one element stiffness matrix, and then we consider global stiffness matrix in order to find out all the nodal values there. Okay. So similarly, I think the objective is same, in this multi-objective, studies, where it is really, really ambitious projects. And I mean, in this particular project, we got around 30% of weight reduction, and almost it's and for aerospace space industry, it is a super performance, I would say. Okay. Now, these kind of beam structure, apart from the weight reduction, you have seen the weight reduction in the regular algorithms. But sometimes if you also give the goal of your strengths, sometimes these partitions, you can set up a goal of, let's say, for example, 200 millimeters of, or let's say, some deflection level under the let's say, for example, 16G crash test. If someone wants to do a crash test, and if you take that particular value and put that goal of, let's say, 200 or some specific maximum deflection, then we can call this this study, the complete study, as a multi-objective design optimization. And then what the algorithm does is that algorithm simultaneously resolves the multiple. Sometimes it resolves multiple, and sometimes it's completely getting a multiple solutions with the multiple constraints. Okay, and that is really interesting. But there is no single winner here. The multiple solutions, all that we can plot, with the Badari has shown you some. These are the kind of plots and the dotted plots, right? So where you can have the trade-off curve, and then based on that, you can take the decisions there. All right. So the next slide. Yeah, here is another. Once we make that the outcome, right? We export it as a CAD format, and we deal with all complex geometries. Like, for example, this is the example of I'm not sure you can see my screen, but it's like a complex geometry in which it's a metal mill. It's a metal welding. The robot it's primarily using the machine learning and computer vision to print a completely a stainless steel version of some chair. That's what we have given these talks, and in this watching, there's no video here, but you can understand that in this printing process, the regenerative shape in real time account for the displacement, right? So in the real time, you'll get the values of the displacement based on that. The new shape and the manufacturing process happens. So this robot, I think it's a combination of machine learning and the computer vision as well, right? So the welding normally what it happens, and it is also a completely a simulation of I would say the heat concentration. During the metal printing process, the parts and overheating sections are especially susceptible for heat deformation. So that is automatically considered on the simulation, and you can see. So these algorithms actually we will have the predeformed digital mode, digital models, so we can get the shape we intended for printing, and that's really key, because if you get that the options in place in the process, it will really help us to find out which is the optimal solution based on which manufacturing methods that I want to adapt. Okay. Now the milling process, the many algorithms the Autodesk has developed that will add the geometry constraints for milling into live milling process. It will also add a lot of value in product design, and you can explore limitless options when you think of materials, and then you think about the manufacturing processes, like for example milling. Okay. And these constraints will really will add a value in terms of exploring which are the right options for you to move to go ahead. Okay. So yeah, and sometimes you may have what we have seen in the process, like all the Badari is represented about. We have seen the boundary conditions. We have set up some design goals. We have assigned the materials. We have applied different types of manufacturing methods, and the generative design tools actually helped us to see the different types of manufacturing ready options. Okay. And that's something it's a practical, and we should look at the that aspects as well. Now, as now we are exploring this generative design, and also looking at the rest of the manufacturing spectrum, like for example, you have a composites, right, or you have a casting design, or you have injection molding. Right. So in all this, you have a comparison, and it really help us to take a design decision on which design you want to go ahead. Sometimes the design could be out of the box, and the design could be a completely different, because we never thought of, your designers cannot imagine such kind of forms. But as we have seen the functionality and the flow of giving the design goals and the constraints within the Fusion environment, which really help us to explore the further designs as well. Okay. And the another also part is we have seen this cost estimation as well, because once we start exploring that the cost per unit versus the performance, where you have a different dots, and ultimately we want to have the product guy, or the companies, or the person who's actually exploring, he should explore the full design workspace, and literally he has predictability from the part design to production, and including the prices as well. And that is really awesome if we think about this trade-off, cost per unit versus the performance, right? And it will also give really fantastic, even a lot of ideas about which manufacturing method I should go ahead, because it will, that prediction allow me to take my decision about some specific product, okay, or specific outcome of this technology, right? Yeah, this leads to some of the discussions, like how we are going to specify the products, right? The future, what we're talking about, the product sense and design themselves. I think the answer lies in understanding the generative design techniques to augment, and also this technology will also have ability to solve the different types of design problems. Okay. So with these things, I think I would like to hand over to Mr. Anand Pujari. Anand, are you there?
Yeah, Ramesh.
Thank you. So
Thank you,
can
Ramesh.
you make Anand as a presenter now?
Anand, you can share your screen.
Yeah, thanks.
Sheriff, we also have some Q&As where we can get some Q&As because the students or the educators or the industry experts may be online. So that's specific questions. The chat box or
Yes.
All right.
In that live session, we are receiving questions and we are just gathering those questions. So once the session is completed, we will post those questions for you, sir.
Okay. Should I start?
Thank you.
Yeah. Am I audible clear?
Yeah. Go ahead. Go ahead.
Thank you so much. All right. Good afternoon, all. My name is Anand Pujari, and I'm an education account manager with Autodesk. I'm with Autodesk for the last 18 plus years, working with different departments. So that was a good presentation by Badari today, and we had certain issues with respect to Ramesh's presentation, but I think overall you got the gist of what exactly is generative design and how we work with generative design as a product to be used. So we all know technology is being used as a productivity tool, right? So imagine if this technology can be used or as a powered tool or partnered with us in our workflow. This is what has led to the generative design. So generative design is nothing but an artificial intelligence based design exploration process. So it's an artificial intelligence based design exploration process where it helps both the human and the machine to create together. And with generative design, the designers and the engineers are now able to spend more time in solving the design problems than just creating the drawings. So we have seen how exactly it works, but now let us understand how our Autodesk customers have adopted generative design in their workflow. We'll see some of the industry customer success stories that will help us to understand the complete usage of generative design and helping to solve the industry problem. So here's the company, Social Hardware, which is an Indian-based prosthetic startup. Their dream is to aid amputees in the rural India. Now, if you look at the report of disability in India, it is 2.21% of the total country's population lives in a disability, and 20% of that population have a disability movement. Now, Mr. Kumar and Mr. Norris, who is the co-founder of Social Hardware, saw an opportunity here, saw a need for a new approach of a prosthetic design to design an upper limb. That's what you see on the left side. So currently, we have two kinds of prosthetic limbs in the market, which is externally powered prosthetic limb versus the body powered prosthetic limb. So there are certain challenges with respect to this. The externally powered prosthetic limb has an issue with respect to the battery, and the body powered prosthetic limb has an issue with respect to its weight. Now, Social Hardware team wanted to achieve a balance between these two. So what they did was they adopted generative design in their case studies. And that's where they were able to come up with a design that can suit both the needs, which can give an aesthetic look to it, as well as produce a lighter weight of their product. So in their own words, Mr. Kumar says that with the use of generative design, they were able to reduce the weight from 300 grams to 96 grams, which is really a drastic change in terms of the weight, and absolutely maintaining the durability or the stability of the product as well. Otherwise, if you look at making these things with a traditional approach, then they would have taken months and with many more errors as well. So it is a lot of iterations as well. So with the use of generative design, not only they thought about coming with a product, but they also thought about connecting to industries like Alimco. Alimco is the biggest manufacturing industry of producing the prosthetists. So they also thought of building connectors, which is to the already existing prosthesis. So that's where they were able to successfully design a product using the generative design, which is supporting the prosthesis. This is one of the case. Let's move to automotive industry. Here's another example from Lightning Motors, right? And Richard Hatfield, the CEO of a small motorbike company, his dream was to build an electric bike which is more promising than the gas-powered bike. So the designers, the team in Lightning Motors incorporated or adopted generative design and additive manufacturing in their workflow to design a lighter and a faster motorcycle. So their designers decided to optimize the motorcycle swing arm using generative design. That what you see at the back end, maybe I'm moving my cursor, this is the design that they have exactly designed and applied in their bike. Now we have to understand one of the biggest challenge in the automotive industry or the motorbikes is the reducing of the weight. And it's not only the reducing of the weight, but we have to, as a designers, we also have to maintain the stability and the comfortability of the ride and not compromising on that one. So the designers, their objective was not only reducing the weight, but they should also give a very comfortable and stability ride to the riders. So that was their objective in overall to adopt generative design. Now, what as an outcome they were able to see was very surprising for them. The new swing arm that they designed, which outperformed the conventional one. So that's what is the power of generative design. Let me switch over to a small without audio, or video, which can help you to see exactly how they have applied generative design in total. And it's exactly would be the quick one what Badari has spent in completely showcasing his design. I know there is a delay in the display that I present. So this is of all the iterations that they got, this is the one that they finalized upon and exactly used it in their product. So let me quickly maximize the screen so you can able to see exactly how the preserved geometries are being created and how the obstacle geometries are being created. Applied, sorry. Identifying the preserved geometry, identifying the obstacle geometry, and considering the different scenarios to build the product. And how each one fits in, different variations as well. You could see the change in the color, the complete rotation, and just fitting it to the bike, and which gives you so aesthetically look as well as meeting all the criteria and maintaining the design output with the conditions that they have applied. So it's not this. They also thought about how they have used Fusion effectively to understand how the total product development innovative platform can be used in designing the swing arm. All right, let me switch back to my presentation. That was another example. Here's one interesting example from our automotive industry, where car manufacturers have adopted generative design in their workflow. Briggs Automotive Company, okay, they not only use generative design in their technology, but they also incorporated traditional manufacturing methods like 3-axis and 5-axis milling to develop a component, okay, which is 35% lighter than the previous ones. So using the generative design, BAC was able to create one of the lightest wheels in the world. And the designers who adopted generative design in BAC were able to explore more design options based on the performance constraints that they had applied in their workflow. And with the use of generative design and the traditional manufacturing method, they were able to drastically reduce the cost to develop this product and to develop a wheel. And for their surprise, what they really saw was the wheel that was produced by BAC was only 2.2 kilograms, which was very impressive and 35% lighter than the previous version. So let's hear directly from them through this small video how exactly generative design and Autodesk has helped them in coming up a wheel that is more lighter in the market in comparison to other ones.
My name is Neil Briggs. I'm co-founder and director of product development here at BAC. The business was founded in 2009. Since then, we've delivered the cars to over 41 territories around the globe. We've been on an incredible journey with our partners, suppliers, and of course our It's inspired by a formula-style layout. The engine is mounted longitudinally along the center line of the vehicle, directly behind the driver, as is the drive line and the gearbox, which is then mounted further behind it. So the hard points of the car actually started to pretty much define themselves fairly easily from day one. We focus on clever use of materials, we focus on our processes, and our clever use of the available softwares that we have to us in order to optimize the components on the car. A classic example of some of the innovation we've got here at BAC is our two-piece carbon hybrid wheel. So we've taken an alloy wheel, the lightest 17-inch alloy wheel in the world, we've made it 2 kilograms lighter. But we weren't content with that. We wanted to move that forward. And that's where we utilize generative design. Work very closely with our friends and colleagues at Autodesk to basically apply the same load case to the same wheel to see where we can optimize the structure. And using the constraint system within the software, it meant that we could constrain the areas of the wheel that the designers were particularly protective about. And that then forced the software to look into specific areas to optimize the weight reduction. And I think the solution that we've come up with is absolutely incredible. We've saved an incredible 1.25 kilo just from the centerpiece alone. So we've moved this lightest wheel already further into just a completely different stratosphere. So the new mono represents the next stage of our design DNA, described by Jeremy Clarkson as one of the most iconic shapes he's ever seen. The car never ceases to amaze me or anyone else who sees it, just how striking it is. And to move that design forward actually was a really tough challenge. The car has got this slightly more aggressive, lower, sleeker, longer stance, which is even more striking and looks incredible.
All right, hopefully you're able to see my screen. Wasn't that very impressive? I mean, how our customers are using generative design in their workflow. This is the new future. This is the new way of thinking or adopting technology in your workflows. I mean, now that we have seen a couple of the industry work on generative design, how our customers have adopted, I kind of presume that there could be some of the academic people participating in this presentations. So let's look at some of the works being done by the academic students. Okay, there's one more case study. This is another example, Will, and it's a startup company from Japan, and they wanted to solve a social problem. They adopted generative design in their workflow. And what you see on the left side, okay, and they used our technology to solve the social problem. And one of the things that I wanted to adopt in their workflow is a more portable electric vehicle with the mobility in mind. And what does that really mean is, when they first developed their product, they got a feedback from the customer saying that if your product would have been much lighter, then that would have been, I mean, if you could have reduced the weight, that could have helped us a lot. And the designers started thinking about how we can apply or reduce weight on the frame and still maintaining the drive mechanism intact. So they started using generative design in their workflow and applied generative design to optimize their frame. And their future plan is to make this as a mass production one using generative design. So even not only in automotive industries, but even the startup companies like Will are using generative design in their workflow and trying to solve the social problems. And to the best, they were the best innovation. They got the best innovation award in 2018 by the CES, that is the Consumer Electronic Show. And not only that, they were also listed by the Times Magazine as one of the top best inventions of 2018. So likewise, these are the different industry customers that have adopted generative design in their workflow. As I mentioned, now let us quickly look at the ones that are being worked by the academic institutes as well. I mean, what you see on my screen is very similar to the complete presentation that Badari showed you. This is a work or a product that is being developed by an institute, an academic institute, Dayanand Sagar University, who adopted when they saw generative design in 2018 at Autodesk University in Delhi. They thought that, okay, this is the technology that we should adopt in our final year project, and that's what you see here. I mean, in 2019, the simple 4-bar quadcopter chassis, and they were able to apply generative design and reduce its, not only reduce its weight, but they were able to successfully fly it as well. And the screen completely shows how different iterations as they worked upon. They have done the simulation part of it. They have done the stress analysis on it, and this is what exactly the actual flying model that they have developed. They're different. They got into 3 different modes. One is an aesthetic look, another is a strong one, and with the different materials as well. So altogether, these are the projects that they were also showcased at different Autodesk events as well. So not only the industry, but the academia is also. So I would encourage the academicians who have access to generative design, try exploring the technology before it is pulled out from you people. So because there is a cost involved in it, you have to have the cloud credits to do the computational of generative design. And here's another example that I would like to highlight from, again, academic. So what you see on the left side, this is an electronics guy, have no clue about the mechanical design aspects at all, but he has won multiple, this team has won multiple competitions with their robot. Using the PVC pipe and everything, what you see on the left side is his actual design. And when we collaborated with the same mechanical guy, so we kind of collaborated with this electronics guy, and what you see on my right side is an output of after we applied the generative design. So different, so aesthetically look, and so compact with it. And this is what is their actual product that they developed and was showcased in multiple events as well. And people who might have attended AU last year and Fusion Academy might have seen these products live working as well. Very interesting from an Indian perspective as well. IIT Madras and Fiat Chrysler collaboratively worked on a lower control arm using the generative design technology. And to their surprise, what they really achieved is the LCA was 26% appreciable in terms of its mass saving. So traditionally, what you see on the left side, which is in like an yellow color kind of a thing, it's a current aluminum casting design. That's what is being used in the FCA right now. but there's a study going on and they're almost close to that one. My colleague Ramesh has helped them in achieving this goal. So now what you see on the green side is the additive manufacture output using the generative design. Some quick examples, the brake caliper, students exploring generative design. What you see on the left side is an actual component, and what you see on the right side is the output of generative design. In the go-karting, fitting as well, what you see on the left side is already fitted, which is the actual one, but as a generative output, you see the way it's been designed with a lighter weight and everything. So what I'm trying to say is, it's both ways. I mean, it's both ways. Both the commercial customers as well as the academic started working and understanding the power of generative design and trying to incorporate that technology into their projects, into their workflows, into their products as well. So in all, what I really want to say is that gone are the days of working silos on a specific software. Now is the era of product innovation platform, where the design, engineering, and manufacturing is going to converge to one. And this is the era of collaborate, and this is the era of cloud. So we definitely have to adopt such newer technologies in our workflow. And what really we are going to achieve through is an instant access of my work anywhere, anytime, through any device. So that's the power of both collaborate, generative design, and cloud. So with that, I think I'm done with my presentations, and now we are open for the Q&A. Hopefully, the information that we share, of course, there were certain issues with respect to the technicalities in our presentations, especially from Ramesh side, but the content was really helpful. Unfortunately, that was not displayed on the screen. But overall, what I would say is, considering all the three talks, I think you got a fair amount of idea exactly what generative design is all about, how Autodesk has developed this technology and has brought this technology to both the commercial customers as well as the academic customers, and how both the commercial customers as well as the academic customers are using this technology in their workflow. So I think it's the right time for all of you to quickly look at this technology and start adopting this technology in your workflows.
Yeah, so I think, Sharif, you can have some Q&As and you can make me as a presenter.
Sure, sir.
So I'll stop sharing my screen.
Yeah, so let's have a Q&A. Any Q&As that you can start.
So regarding the generative design license, cloud credits, we received a query, and a participant asked us that for education license, how much cloud credit is given for an education account license?
Okay, so you know, for education, if we have, I mean, you know, educator or a student, once the students will register with their, you know, respective institute ID or Autodesk Education Community, so they will get the license, which for generative design with unlimited cloud credits. But if you're using the common the email address, for example, Gmail or maybe some Yahoo and other portals, I think that we have some challenges. I think we cannot give you that kind of, you know, access and the number of cloud credits to the students.
I think for them, those who are using a Gmail or a Yahoo account kind of general email IDs, they get 100 cloud credits. But those who are on their domain email IDs of the academic, they will get a full access to the generative design.
Thanks, sir. So, and one more question is that, thanks for the response. And so one more question is that, so as you said that the generative design helps the engineers to complete that, go for the alternative design. So what is the difference between shape optimization and generative design? So that's one of the questions which we received. What's the difference between shape optimization and generative design? How they are differ, since both of them are available in Fusion 360, how they are differ?
Yeah, so I think the main prominent difference is in the shape optimization we have a single outcome, but when we start talking about generative design, we have a multiple validated option. That really gives the idea and the broad perspective in terms of understanding the design exploration space and multiple validated solutions with the cost comparison and with the performance trade-offs.
So the last question, which I received. So once the model, as Badri sir have showcased that drawn design, once the model is being subject to the generative design, the finished model. So will it be the right one to get fabricated, or we need to do some additional modification to the parent model? So is there any need of that? The model, what is received, is it enough for us to fabricate?
Of course, it is possible to fabricate, but yes, it depends on the requirement. If they really need to modify that, software will give 100% access to edit the model. So whether they want to add, whether they want to edit the design, so they have all the functionality tools available to edit. If not, they can directly go with the fabrication, whether it is 3D printing or using Fusion CAM, they can generate the tool part to execute the same.
Just to add, if you remember the quad copy that was shown in my presentation, if you look at the first design, they didn't have the upper bars at all because then when they did the simulation test on it analysis, they had a little issues with respect to that. So they kind of used that model to edit and created another bar as a supporting bar on the upper end as well. So that's how what Badri said is absolutely right. So the model, it depends upon your requirement, and you can certainly edit those models to give a better strength. And of that, you get multiple variations. So you have to decide which is the one that exactly suits your need.
Yeah, you're more. Sharif, you're on mute.
Thanks for quick response. Thanks for the response. So we have received one more question from Dr. N. Pungulili. So in the 3D model shown in the lecture, how to control the mesh parameter in 2D and 3D? So that's a question being asked.
Okay.
So how to control that?
Yeah. So I mean, this is primarily question in terms of the synthesis process, because in the generative design we have a provision which is called as synthesis, and with the help of simple slider, we can take a call whether we want to go ahead with fine cores of synthesis, because that synthesis, if we say fine, there'll be more number of nodes, and the synthesis will be much more refined, but it will take a longer time. However, if you decide to go ahead with a coarse synthesis in Fusion, then it also saves the time, and also you have the minimum number of mesh, the number of elements on the model. So we can, based on the synthesis settings, we can decide the quality of the mesh.
One added to the session, and asked from Pudale College. Their question is that, so the model generated using GD as a future, whether we can edit from future tree, whether we can edit it post that question. I think can be asked to, as a model which is output from the generative design, whether we can edit that model.
Of course, all these models are CAD ready, but yes, it is also editable. As I mentioned, every single generative design extracted CAD model will be a free-form shape. So any point of time, they can go back to the history, double-click on the free-form icon, and they can edit the model. Once they exit from free-form, again, it will be considered as a solid model. So if you want to add, edit, subtract, or anything you want to do on this generative design 3D form model, so every single feature is available. There is no limitation in terms of editing the model.
Well, so Yeah. So those are the questions which we received in the chat area. And to add a point, and so I think is there anything that the and Dr. Ramesh sir to provide as a note to the participants from these questions?
Yeah. So as a note to the participants, I would like to share my screen here. I don't know if I can share my screen now. Okay. So I hope it can. So I think all of you can, you can go to the Autodesk Design Academy. You know this Autodesk Design Academy, where you can look at the latest learning content and the curriculum that what we have given for all of you. And the simple way is you can take up a course, right? If you want to start with a specific course, the steps are or the flow is very simple. You have all these new courses, like for example, the courses on generative design, the courses on structural analysis, CAD, CAM, and CAE. But I mean, for learning this new technology, what I would suggest you is you can go to this portal, visit the portal, pick these courses, take up these courses, because these courses will really give more value in terms of the different workflows and the steps what we have mentioned in this, because these courses, okay, and I think it's not clicking here. Okay, so those are the great ideas where someone can visit, enroll for this course. So these are something intermediate level courses which has some specific the objectives, the different types of lesson plans, and the students, or I mean the educators, will start learning this package from the basics, and they explore the complete workflow under generative design, up to a collaboration, and also sharing the outcomes with the team members. So these are the and also at the end of the day also they will have the core challenge as well as the next steps. So this is something I would strongly suggest, because as they can use Fusion as a the primary tool, and once the software is up and running on the system, they can visit this website, Autodesk Design Academy, take up this course, and then complete this course to get the certificate as well directly from Autodesk. So this was a little bit information on the learning content as far as the generative design is concerned. Anand, you would like to add something? Yeah, please. You're on mute, Anand.
Thanks, Ramesh. Yeah, that was absolutely right. I mean, good that you shared the screen and showed Design Academy is one location to go after, and you have around good content in collaboration with the industry experts. So if you take this course, I'm pretty sure that you will understand exactly what Badari showed in his presentation, the same workflow. So yeah, there is a content available. Please utilize this content and even earn a certificate of completion as well.
Yeah, Badari, do you have any final comment?
No, all good. So thanks for the opportunity, and yeah. So the final conclusion. So it's already 1:30. So thanks ICT Academy for organizing all this, and really appreciate all your support. And thanks to the team members.
Thanks very much, sir, for your support and for your